Alright, so here we're going to look at the chapter 4.1 through 4.7 quiz. Number 1, find the vertex of the above equation. Show all your work. That's utilizing negative b over 2a. Our b value is a negative 12, so we got a double negative situation there. And we got a 2 for our a. So we'll get a positive 12 divided by 4. So our x-coordinate of our vertex is a 3. Also tells me my axis of symmetry is x is equal to 3. Now to find the y-coordinate, we're taking our original equation and plugging in that x value. So we plug in our 3. 3 squared is 9, times 2 is 18, minus 36, plus 3. Add those up, we'll get a negative 18 plus 3. Tells us that our y is a negative 15. Alright, so is this a maximum or minimum? Well, the a value on our formula is positive, which means we open up, and our vertex is that 3 comma negative 15. So that's really all we need to know for that our vertex is a minimum. It's at the bottom as we open up. Y-intercept is always 0 comma c value. So 0 comma 3. Alright, and so moving on to the domain and range. Domain for quadratics, always all real numbers. Now the range starts off like this, talks about the y values we're in between. The lowest we ever get, you always want to take that y coordinate, so we take our negative 15, put a line under our inequality, and then we open up, so we will approach infinity. Alright, so for this one, given the quadratic in standard form, they're giving us 3 coordinate points. So this is where we're going to take our standard form, and I'm going to plug in my x and y coordinates in for all 3 of these to find the coefficients for a, b, and c. So in this one we'll have 20 is equal to a times negative 3 squared plus b times negative 3 plus c. It's for this first coordinate point. I'll go ahead and simplify that down and move the y to the other side to get us a 9a minus 3b plus c is equal to 20. Alright, now let's do this point, where we've got 7 as our y. Our x value is a negative 2. Alright, simplify that one. Negative 2 squared is 4, so I'll have 4a minus 2b plus c is equal to 7. Do the last point here, we got 15 is equal to, plug in 2 for x. So we'll have a 4a plus 2b plus c is equal to a 15. Alright, so if we put these into a matrix, 9, negative 3, 1, 20. 4, negative 2, 1, and 7. 4, 2, 1, and 15. And we type this in an RREF to solve for the systems of equations. When we RREF it, we get this matrix here. And this tells us our a, b, and c value. So for my equation, which we'll go back over there in that form, but I'll write it here, y is equal to 3x squared plus 2x plus 1. Alright, this time they've given us 2 coordinate points. One of them is our vertex, so we're going to need our standard form. Vertex form. But we know our vertex, so I'm going to go ahead and plug in my h and k values. So my h is a 2, so here's our 2. My k is a negative 1, so I'm going to put a negative 1 there on the outside. Now I'm going to use this coordinate point as x and y to help me solve for a. So I've got 7 is equal to, plugging in this 4 for the x, so 4 minus 2 squared minus 1. 4 minus 2 is 2. Square that gives us a 4. So 4 times then the a. 4a minus 1 is equal to the 7. Add the 1 to the other side. Divide by 4. And get that a is equal to 2. So we just take that 2, plug it back into a there, and that's our answer. So we have y is equal to 2. X minus 2 squared minus 1. All right, solve each by factoring. You must show your factors to get full credit. This one here factors 2. It's the easy type, so x and x. See, it's going to be double negative. And this would be 6 and 3. A part that a lot of people forgot is to set these pieces equal to 0. So your answer is not just x is equal to negative 6 and x is equal to negative 3. You have to then solve for x after you set the pieces equal to 0. So we have positive 6 and positive 3 after you would add 6 to both sides to solve for x. This one here, I know it's going to start off 5x and x. Only factors of 2 are 1 and 2. I also see, again, this will be a double negative situation. Need my 2 here, my 1 here. Now, set these pieces equal to 0. This one should be pretty obvious. You'd add 2 to both sides. This one, if you wanted to see it, add 1 to both sides, divide by 5 to get that x is equal to a 1/5. This one here, it's another easy type, except this one's going to be a 1 positive, 1 negative. So I'll need a negative 6, a positive 5. If you set up both of those equal to 0 and solve, you will get a positive 6 and a negative 5. All right, so taking a look at the back. Solve each equation by using square roots. Simplify your square root if necessary. Remember, we want to solve these like a regular equation, and we reserve taking the square root until the very last step. Divide both sides by 2. Now, when I square root both sides, cancels that out. Don't forget about your plus or minus. All right, this will give us x is equal to plus or minus 5. The square root should have covered both the 2 and the 5, sorry. All right, so here once again, save taking that square root for last. All right, when I square root both sides, since we're in equation, we have our plus or minus and an 8. This one here, similar concept. 3x squared is equal to, so we're subtracting 7 from both sides, 36. Divide both sides by 3. Square root both sides. I can simplify 12 into being 4 times 3, square root the 4, to get a 2 square root of 3. Don't forget about your plus or minus. Completing the square. This is where we want to ultimately factor it down to the same thing twice, so quantity squared is equal to a number. First step on this, move the c value out of the way. Add 5 onto both sides. That clears us up some space to find what that number needs to be. Now, we want this to factor to the same thing twice. That way we can simplify it down to being that factor squared. So if this has to be the same thing twice, I know that these numbers have to add together to give me 6, and they have to be the same. So that's really just thinking 6 divided by 2, which is positive 3 and positive 3. If I multiply 3 times 3, that means there's going to be a positive 9 there. And I need to add that to both sides to stay balanced. Now we can factor x plus 3 times x plus 3 to x plus 3 squared. And then we're ready to square root both sides. That frees up our x plus 3, leaves us equal to plus or minus square root of 14. There's no perfect squares in that, and so we're finished once we subtract 3 onto both sides to get that x is equal to plus or minus the square root of 14 minus 3. All right. Simplify the following equation with the quadratic formula. So we've got our negative b plus or minus square root of b squared minus 4ac all over 2a. Alright, so we got a negative 9 here. Our a is a 2. And our c is a negative 35. Simplify just a little bit at a time here. So out front I have a negative 9, so we got a positive 9, plus or minus. Negative 9 squared is 81. This is where a lot of people messed up. I need to do on this here, this is a negative 4 times a negative 2 to get a negative 8. And then negative 8 multiplied by the negative 35 gives us a positive 280. And then we're all divided by 4. So this simplifies down to 9 plus or minus the square root of 361 all over 4. 361 is a perfect square. It's a perfect square for 19. So we have 9 plus or minus 19 over 4. Since we have plus or minus, we need to do both 9 plus 19 divided by 4 and 9 minus 19 divided by 4. Do the numerators first. 28 over 4 gives us a 7. This is negative 10 over 4, which will simplify to a negative 5 over 2. Those are our two answers. We have x is equal to 7, and x is equal to a negative 5 over 2. Alright, so on this you're matching up the picture with the proper number of solutions. No real solutions means when we do not cross, nor will we ever cross the x-axis. That's this one here. Alright, this parabola will never cross the x-axis. Two solutions is when we have two spots that we're crossing the x-axis. That's right here. Alright, we see 1, 2 spots. Which then means one solution is where we just touch the x-axis once. And that's right here. Here is our one solution.